So for this video, I'm going to introduce the concept of derivatives. So what is a derivative? Well, the derivative is the slope of a line. So here I have a few examples, and we can try and calculate the slope of each of these lines now. So let's look at the first line here. So say we have the line y equals 4. Well, that's just going to be a straight line that's 4 up in the y direction. So let's calculate the slope of y equals 4. So we'll use the general slope formula. So for the general slope formula, what we need to do is we need to pick 2 points on the line and then find the slope between those 2 points. So this is just a straight line, so we can pick any 2 points we want. So let's pick this point here. So we're going to label the coordinates of the point x1 and y1. So this point is located at the coordinates 0 for the x and 4 for the y because it goes up 4 here. So x1 is going to be 0 and y1 is going to be 4. So that's our first point. So now let's pick a second point. So for the second point, we can pick any point we want along the line. So let's go 5 over here. So here we've gone 5 over in the x direction. So we're going to label this x2, y2. So we've gone 5 over in the x direction. So the x2 coordinate is going to be 5 then. And then the y2 coordinate is going to be the same as the y1 coordinate because we haven't gone up in the y direction. So y2 is going to be 4. And now we can use these coordinates here to calculate the slope. So our y2 is going to be 4. And then y1 is also going to be 4. So we have 4 minus 4 in the numerator. And our x2 is going to be 5. And our x1 is going to be 0. So then if I calculate this, I have 4 minus 4, which gives me 0. And then 5 minus 0, which gives me 5. So I have 0 over 5, which just gives me a slope of 0. And that makes sense because the slope of a line is going to be its rise over run, meaning its increase in the y direction divided by its increase in the x direction. So because it's not increasing in the y direction, that means we have a slope of 0. So we just said before that the slope of a line is the derivative. So we know that the derivative of y equals 4 is just going to be 0. Now what about the line y equals 3x? So here we still have a straight line, but it's increasing in the y direction now. So we should have a slope that's not 0. So let's calculate the slope now. So we'll use the same formula as we did before, and we're just going to pick 2 points along this line. So we'll pick the origin here. So we're going to call this x1, y1. And we said this is the origin, so x1 is going to be 0, and y1 is going to be 0. And now let's just pick a point along here. So let's pick the point here. So we're going to call this x2, y2 for the x and y coordinates, just like before. So the x-coordinate for this point is going to be 2, because I've gone 2 over here. And the y-coordinate is going to be 6, because I've gone up 6 here from the origin. So now we have the coordinates for the 2 points, so we can find the slope between those 2 points. So we're going to follow the same formula now. So our y2 is going to be 6, and our y1 is going to be 0. So I have 6 minus 0. And it's going to be divided by x2 minus x1. So my x2 is going to be 2, and my x1 is going to be 0, so I have 2 minus 0. So this is going to give me 6 over 2, and 6 over 2 is going to be 3. So my slope is going to be 3. So like I said, the derivative is the slope of the line. So my derivative for this line is going to be 3. Now, let's go over some notation here. So normally when we describe a line, we describe it as y is equal to 3x. But we know that y is a function of x, which means that y depends on x. So if you plug in values for x, you get different values for y. So that means y is dependent on whatever x is. So if y is a function of x, which means it's dependent on x, we can write this in a different notation then. So we could say that y is equal to f of x, which just means it's a function of x. So then that means that f of x is equal to 3x. Now when we describe the derivative, we can call this f prime of x. So that just means the derivative of the function. So since we calculated the slope of this graph, we have its derivative. So that means that f prime of x is going to be 3. So now let's say we don't have a straight line. So let's say we have y is equal to x squared. So let's use the function notation again. So we have x squared is a function of x, because it depends on x. So now we don't have a straight line here. So how do we find the slope of a line that's not straight? Well, the slope is going to change along that line. So if we have a curve here, like we have for y equals x squared, we can look at the slope at individual points then. And to find the slope at an individual point, we draw a line that's tangent to the curve. So for example, if I have this point here, we draw a line tangent to it, which means we draw a straight line that just grazes the curve at that point. So a tangent line is going to look something like this. So it's just a straight line that just touches that point and keeps going straight. Now what about if we pick a different point along the curve? So let's say we pick a point up here. So let's draw the line tangent to this point. So this line is going to have a much greater slope than the line at the other point down here. So that means, like I said, the slope is changing. So if you start lower here along the curve, the slope is going to be less, but then as you go up the curve here, the slope is going to be greater, because the tangent line has a steeper slope. And then if you go all the way down at the bottom here, the slope is going to be flat like this, because the tangent line is a flat line here. So it's going to have a slope of 0 then. So how do we find the derivative, which is the slope, of a line that's curved like this? Because if the slope's changing, it's not going to be a constant value like we have for the other two graphs. So what we can do is we can use rules of derivatives to find the slope for graphs that aren't straight. So for functions that aren't linear like this. So the derivative for this happens to be 2x. So we have f prime of x is going to be 2x. And the way we can find this is we could use different properties to find the derivative of any function. So we're going to go over those in the upcoming videos then. So the derivative here is going to be 2x. So what that means is if we plug in different x values, the derivative is changing each time. So for example, derivative at x equals 2 here, we could look at the formula for the derivative, which is 2x. We plug in x equals 2, so we get f prime of x is going to be 4. What about at the point x equals 4? So if we plug in x equals 4 in the derivative equation, we get 2 times 4, which gives me 8. So at this point, f prime of x is going to be 8. So the derivative is changing at each x point we choose, so that means the slope is changing. So we get what we expect then, we get a changing slope.